All right, well, I was hoping Dr. Nelson would come because I'm not sure what format this is really supposed to take, but I'm guessing we shouldn't count on him being here for this part since we're 7 minutes in already. So how do these things usually go?
Usually they've kind of just walked through like a basic summary of the lesson and then just we ask questions, give input, whatever.
Okay.
That's how it's usually gone.
All right. Do you all see that I'm sharing my screen?
Yeah, we can see it.
Great. All right, so I guess I will skim through this and go through the parts that I think are important for you to get. And then we'll go on to questions and see what happens. To start, I think this problem statement that I wrote is probably one of the most important things that you could take away from this, is that we aren't trying to tell you that you have to be a phenomenal computer programmer. If you love it and become good at it, it will help you and you will go farther and get to do cooler projects and whatever, but you don't have to be a computer wizard to be functional in our lab and to contribute to meaningful research and to make cool products and whatever. It's just kind of a byproduct of the fact that because we're doing research, there isn't a commercially available, tried and true tested software or program or whatever for whatever problem you face. And for me, when I started about 2 years ago now, I had this like major identity crisis that I was a civil engineer and I just got recruited into this lab that wants me to learn all this programming stuff. And for like the first 3 weeks, I thought there's no way this lab is for me. I need to get out. I signed up for the wrong thing, something like that. But then someone explained to me that like there's no pressure to be a computer wizard. So don't feel overwhelmed if people start talking about a lot of computer science things that you don't know. But our emphasis is still going to be on civil engineering projects, and you'll still be doing the same kinds of reading graphs and data tables and stuff that you might have expected going in. So I guess really my takeaway message is don't panic if this programming stuff seemed like not your jam. There's plenty of other things to do, and it's not like the only thing that we do. Moving on, this is prereq stuff for the class. So backgrounds. Why Python? Python is the language of choice for data scientists because it's fast, like it runs quickly. It's also easy to learn. And a lot of the leading GIS softwares have a Python package that you can control all of their GIS functions with, like ArcGIS and an open source one called QGIS, which you may or may not have heard of yet. It's very similar to ArcGIS though. They both can be controlled through Python scripts. And since a lot of what we do is GIS based or has some kind of components in that, it works really conveniently if we all share the same language. That's kind of why Python, I guess. This stuff about computer programming and different kinds of languages, it's useful to know, and I think it helps orient you, but I won't spend too much time going over that right now unless you have questions to ask me later. Let's move on to this one. This lesson expected you to spend a good amount of time learning Python if you didn't already know it. So I guess my question is, did you try any of these learning Python links that we provided? Was there one that you liked, one that you didn't like? Did you feel confused? Do you have any feedback about that? For any of you?
I really liked the first link. I thought it was really helpful. And I did a few exercises in that. I actually haven't spent as much time on the second two links. But I do feel like that first one, the learnpython.org, which is a really good base for, like, I didn't know really anything going into it. And so I thought it was a pretty good base to kind of figure out what's going on. A good base to start out with, I guess.
Okay, good. I think that Learn Python one is one that Dr. Jones recommended. I haven't personally looked through that one, but he said it was good, so that's what
The hardest thing that I was having with like any of them is that if you don't like, there's no way to like they give you good exercises and kind of run through things, but there's no way to kind of like hover over what you're doing and like see specifically what each component means. Like I feel like that it was like missing that. So I don't know if there's like another website that has a little bit more like, I guess, like reading instruction, like this is what this is telling the computer to do, because I feel like understanding what each component of the code is doing like really helps. So I feel like it was kind of lacking in that area.
So you wanted to be able to like hover over when you typed print and have it explain, oh, print is what makes it show results or something like that?
Right, yeah, or like when it was like percent, like, you know, it's like percent %s and then you like add the string in that gets inserted there.
Yeah.
That took me forever to understand just because it didn't have it written out. Like, oh, this is what's going on. You have to like kind of stare at it and like figure out what's going on, which is fine. But like, it would be helpful if there was a website that kind of like gave you a little bit more like explanation, I guess, or like instruction in that way.
Okay. That's good feedback.
I totally agree with Tessa. That one took me forever to figure out too. I think like a lot of it, like they explained things they explained things pretty well, but then you got to the end of the section and it had an example that like included other things that you haven't learned yet. And so that kind of is what threw me off. But I think the second link, the Scribble one, I think that one explained things a little more in depth, or it walks you through the examples. It's like a video, and so that one might be helpful if you run into things like that.
Yeah, the Scrimba has videos, I think, with all of them, doesn't it?
Yeah.
Okay.
Yeah, they're all like videos, and then he'll like you like pause the video and edit his code to like do the exercise, and then he comes back and explains it. Which is pretty cool.
Well, good. Anyone else try others or have any other feedback?
So Tessa and I found one called Udemy, something like that.
Yeah, Udemy.
I really liked that one because it had a large range of like skill levels and stuff. Because the Learn Python one was pretty easy because I've already taken Python in college. So it was like good to kind of like refresh some things that I probably forgot. But the Udemy, like I could go in and I could find a video or like a lesson about one was like how to do rock, paper, scissors on Python. It was really cool. It just like walked you through the process. And so I could like follow along and do it on my computer. And like I could change the code if I wanted to like have it make more sense. So that was really cool. And it had like beginner to advanced.
Yeah, good. I'm glad you found that one. I originally had the Udemy course linked here, but the professors thought we ought to start with something even simpler, so we ended up deleting it later. But glad to hear you liked that. Maybe we'll consider putting that one back in as an option.
Or maybe you could even like I know the one lesson that I was working on putting into EDX just had like an appendix with like other learning resources. So you could even just like put it at the end there or something like that.
Yeah, that's a good idea. Anybody else? Great. Well, the next thing I would ask then is there anyone that doesn't feel like they're comfortable working their way through these kind of guided examples? Did anyone like not make it all the way through or feel like they didn't learn enough out of it? Is there anyone that feels lost? And if you don't want to admit that now in front of everyone, that's okay too. I will, you can message me or something and we'll work through it. All right, I will talk about this section on scripts and packages and package managers for a little bit. This is going to seem an awful lot like just semantics and naming conventions and things. And to some extent it is, but at least for me, I found it was very helpful to have someone like draw the difference between things, because otherwise you just kind of start talking and you get into these discussions where one person is saying package and another person is saying library, but they mean the same thing, but you're sitting there like, are they the same thing or are they not? And I think a lot of people in the lab still don't really grasp what Conda and PyPy are for. So I tried to explain that in these paragraphs. I'll see if I can explain it any better now. The first thing that I talk about is that I would call those little example things that you coded up in the lessons scripts. They do one job. There's no functions. I mean, a script could have a function in it, I guess, but it kind of just has one purpose, and it's just basic code written in a file somewhere that you've saved. And then a lot of what we do is more towards moving towards the idea of a package piece of code. So like the example I give in here is if I write a program, a little script that lists all the files in the downloads folder, that's one thing I can do. But if I want to list the things in the documents folder, that's related, but it's not the same thing. Or if I wanted to make a new folder or make a new file or something like that, those are all very related tasks, but they're different. I can't use one script to do all of them. So the way that you address that is you can make a package of code that does a bunch of related tasks and handles a lot of similar challenges. And so, for example, in Python, there's a package called OS that's built into Python. You don't have to do anything special to get it installed on your computer after you get Python. And it means operating system, and that's what lets you interact with the files and directories. And with that package, there are tools in it to list what's in a folder and to make a new folder or delete a folder or make a new file or something like that. And then you can share those packages with something called a package manager. So suppose, like I just wrote a package recently for doing GIS type stuff on time series of spatial data. And so I published that with these free services called package managers. One is called the Python package index, and another is called a mini conda. However, people will sometimes call it conda or anaconda, but in the lab, they're all referring to the same thing. And what these package managers do is it's kind of like when I put a Word doc or something on Google Drive so that I can share it with someone I'm in the same class with or something. Maybe I'm typing my notes in it and I want to share it with someone. It's kind of that same kind of idea. Conda and PyPy are not code that you use, so you won't write a script or an app or something that uses PyPy. It's just a service that helps you share the things that you've already made. Does that make sense to everybody? Is anyone lost on or have questions on what the difference is between a code that you're writing, scripts and packages, versus the package managers? All right, we'll call that good then. There's some notes here about how we name and version code. So when you share your code with other people, you have to give it a name so that you can do, I don't remember now, but in those examples, did you all get to the part where you did import something at the top of your code?
Yeah.
Yeah, okay. So those imports, whatever name, and the version numbers, this is notes on how that all works. It's not super critical to know right at the beginning, but the longer you're here, it will become very important that you understand this idea of versioning. It's not complicated, but there's just some rules to be aware of. And then the last thing I would cover is virtual environments. So a virtual environment it's literally only a folder on your computer. It's gonna, I think a lot of the introductions you read, if you were to go Google this and try and have someone else explain it to you, they get a little complex. But literally all it is a folder. When you install Python or Miniconda or something, and you use a package manager to create a virtual environment, it literally is just a folder on your computer. And it's a tool that we use to organize different versions of our code that we've put on our system that we've installed. And I think of it kind of similar to a virtual machine, in that I don't want to, I don't want to do everything just on my own computer. So sometimes I'll make a container, or sometimes I'll make a virtual machine so I can keep things isolated and test things in their own little compartments without risking breaking the rest of my computer or ruining the other softwares that I have installed. So what you put into a virtual environment is you'll install Python in it. And it might seem weird that you would install Python a lot of different times, but in each one of these folders, these virtual environments, you install Python, and then you can choose to install whatever other dependencies that you come across that you'll need. So like a good example of this is in our lab, we have a homegrown web app framework called Tethys. It's a customized version of some other open source softwares. And that you install that through Miniconda. You create a virtual environment, but the dependencies in there are kind of temperamental, and you don't want to break them, otherwise it breaks all of your web apps. So you'll create a virtual environment, a folder, where you're going to save all of your Tethys web app things. And then separately, when you're working on other projects, you'll make a new folder, a new virtual environment, where you'll install a second copy of Python and what other dependencies you need, so that if you break one virtual environment, you don't lose everything. So I don't risk breaking my installation of Tethys, my web app stuff, when I'm uninstall or upgrade versions of something I'm working on for a class or for whatever I'm using my other virtual environment for. I feel like that I didn't do a great job explaining this, but does anyone have questions about that? I can try and work on this more, but I didn't realize I hadn't finished writing the paragraphs on it until today. Does anyone have questions on what you use a virtual environment for or anything like that?
I just had a question. Maybe I missed it, but what exactly is a dependency?
Yes, I must have skipped that. So a dependency is when you type import something at the top of your code, you're using code that someone else has written and your code can't run without it. And so you say your code depends on that code. And so that thing that you imported at the top, the other person's code that you're borrowing is the dependency.
Okay. Okay.
That makes
That makes
sense?
sense. Yeah.
Just a quick question. So Tetis is like, if I understood, it's kind of like a custom library that you guys built, or is it kind of like just packages, a collection of packages, or like, what would it be exactly?
So Tethys is Django, some customized pre-built post-GRE-SQL databases. And then it's also has a command line interface, which I'm sensing you kind of already are familiar with a lot of these ideas, but
Yes.
it's shortcuts for using Docker to create containers and to
Got it.
start Postgres and things like that.
So usually the apps are like, do we work usually, or Tetis works with APIs, or just it, or does we connect to a service through a container? We create our own version of the container. I'm just trying to understand this a little bit more, just so.
I'm not sure I understood your question. Could you ask one more time?
So that is like the apps that they are there, are they custom apps that work with an API, or they're like virtual environments that they are developed like someone else and we just connect them, or we have keys to connect? I just want to know like if it's kind of like a shell to administer those containers or APIs. Are they usually APIs or containers? Or
so Tethys is, you can think of it very much as just Django. It doesn't do too much beyond just Django.
okay.
It was created by a PhD students in the lab several years ago now, but he's gotten funding to keep working on it and keep growing it. He works at Aquaveo, and his name's Nathan Swain. You might hear about him. You'll probably hear his name around the lab. But his idea was, if I wrap up enough of the things that you need to do to make a web app that's a lot of engineering and science applications would be better demonstrated in. If I can wrap up a lot of those things in a neat little package and write a lot of documentation about it, then you can lower the barrier. That's the term you'll hear a lot. We can reduce how much you have to know and be an expert in before an engineer can turn into someone that can share his work through a web app.
Okay. Okay, it makes sense then. Okay.
Yeah, you'll all hear the term lower the barrier a lot around here. All right, any other questions about this? Well, great. Skipping down to the quiz, I noticed I had already highlighted all the answers. I never unhighlighted all those. So my mistake. But did you all make it through the hands-on practice or have questions on the quiz?
I've just been working through the online Python stuff, so I haven't gotten to those yet.
Okay.
I don't know about everyone else.
Yeah, Riley, I got a question.
Okay.
I don't know how to put it exactly, so bear with me.
Okay.
For we're making some environments and stuff on the terminal. Why, I guess, when we would use those environments, or why would we have multiple environments to use instead of just using just one that has everything on it?
Right, good question. So one good reason why you would want multiple environments is to manage different versions of code. So for example, like Python itself upgrades from time to time. It's not stagnant. We're actually on the third version of Python. So everything we're doing is Python 3. But it was just at the start of this year that Python 2 was officially over and deprecated. And that's the coding word for don't use this anymore. You should upgrade to the newest stuff. But that doesn't mean we finished upgrading all of our Tethys apps that used to run in Python 2 to Tethys 3 and Python 3. So we have two environments. We have one that runs in Python 2 and uses versions of common data science dependencies that run in Python 2. And then we have a second environment that has Python 3 in it and has the Python 3 versions of the data science dependencies and so forth, because they don't mix. You can't have two versions of Python installed at once. So we have to keep them separate until we have upgraded all of our old Python 2 code into Python 3 code. Does that make sense?
Yeah, that makes sense. Follow-up question.
Okay.
The environments that we're using, that goes straight to like our Jupyter notebooks or whatever. Just kind of looking ahead at the next lesson. Because like if I open up Jupyter Notebook through my terminal with a specific environment, then my Jupyter Notebook would be in that environment. Is that correct, or am I thinking wrong?
Yes, that is correct.
Okay. Cool.
I haven't read the next lesson, but it will probably tell you to install Jupyter Notebook, and just like you were saying, if you want to be able to use other dependencies in your Jupyter Notebook, you need to install them in that same environment that you install Jupyter Notebook in.
Cool.
Good question. All right. What else would I possibly want to ask or go over? Does everyone feel like they understand the difference between a package or a dependency and a package manager? Or I should ask the other question. Who does not know the difference between a package or a dependency and a package manager?
Can you go over that again?
Could you go over the package manager again?
Yeah. So there are, when you have written code that you want to share with other people, the term for that code that you are sharing with someone is called a package. And the way that we share code in Python and other coding languages is through use of something called a package manager. The name of the package manager that we use in the lab is Conda or Mini Conda or Anaconda. They're all referring to the same thing. And the role of the package manager is it knows the names of everyone's code and where to get them on the internet. So you can look up on, like, let me show you an example actually. So the CONDA-FORGE is an organization that uses Conda, and they have a list here. So I can go to the list of packages, and there are just thousands upon thousands and thousands of different packages that someone has written and decided they're ready to share it. And so for any one of these, the package manager knows its name and what version it has, and I can use Conda to download it so that I can get my own copy of it. And so Conda itself is not code. It's just it's kind of like an app store, actually. It's not a bad way to think about it. CONDA-FORGE is like an app store for Python code. I use, when I want to install a new app on my phone, I go to the Google Play Store or to the App Store on iPhones, and then I just click on the code I want and I download it. And it works very similarly with Python and the package managers. So CONDA-FORGE is my app store, and I say I want to install this 2D fat mic code. I don't even know what it does, but I can click download on it, and it will. Well, first it's going to show me the place where the code is stored, but I can use Conda to install it just like it was an app on my phone. Does that make sense? Did that help any, or should I try another way?
No, that's perfect. Yeah, that's great. Thanks.
Let's see, what else would I ask?
I have a question.
Yeah,
So on CONDA-FORGE, can like anyone put code on there?
yes, anyone can, and it is free.
Okay. And is there any like way to prevent against viruses or anything, or do you just have to like make sure you trust the source first?
So that is a good question.
Is that an issue, I guess?
So Python code doesn't quite have virus concerns in the same way that you're probably used to thinking about them. Just installing the code itself, and this is actually a good example of another reason why I would use a virtual environment. When I install Python code, I can put it in a virtual environment, and if I don't trust the source it's coming from, the code is only installed to that folder where I've installed the code to, that virtual environment folder. So if I later find out that code doesn't work, or it's trying to do something I don't like, or it's like it gets my computer stuck in an infinite loop and it breaks things, then I can delete the virtual environment, and the code is not able to break the rest of my computer.
Okay, cool. Thanks.
And CONDA-FORGE is a pretty reputable place to get packages from. On PyPy is the other option I talk about in the lesson, and that one, it has less filters on it. There's a community that monitors CONDA-FORGE and kind of filters them, and they go through some minimal, but there is a vetting process, even though it is minimal. But PyPy, you can put anything on PyPy. So if I had to say, like in terms of things that you can trust, if it's on Conda, someone has put more work into it, and it's probably more dependable than on PyPy. But that's not a perfect golden rule that works all the time.
One more question with those Conda packages.
Uh-huh.
So when we call import, like we import a Conda package, that's a dependency. But does each package have its own dependencies?
They could, yeah. So like I mentioned, I just wrote a package that, and I can do a demo for you, actually. I'll do Conda creates a new one called demo environments. You all see the terminal window, right?
Yeah.
Yeah.
So I just made a new environment here, and I'm going to activate it. And if you haven't gotten through the hands-on exercise yet, this might seem really foreign to you, but it will make sense when you go through the hands-on exercise. But we see that I'm now in the demo environment. And if I do conda list to see what I have installed in my environment, I have nothing. It's empty. So suppose I want to install just one package. And I will say Geomatics is the name of the package that I just recently finished. So I'm going to install that. And you think that's just one dependency. But when I press enter, it's going to think and see what it needs to install. And it wants to install an awful lot of things. These are all the new packages that it's going to install, even though I only asked it for one thing. So when you do import geomatics in your code, you're really indirectly importing all of this. So to answer your question, yes, packages, a dependency can have other dependencies. Does that make sense?
Yeah, thanks.
Mm-hmm. All right, well, I think that's all I've got to say. So I will stick around if you have more questions. But otherwise, I think that's good. That was about, what, 35 minutes after we waited to start? That's pretty good.
So Riley, are like NumPy and Pandas, those are packages, right?
They are, yes.
Okay, so like if you had a program that utilized those, then those would be dependencies.
Correct, yeah.
Gotcha.
Do you happen to know where the recordings are posted?
No idea. Says Dr. Nelson is the host of the meeting, so I guess you could ask him for the recording of it if you'd like.
Cool.
One other comment I think I would make is that the answer to number one is kind of related to Evan's question earlier from knowing about which environment you're in when you install packages. So make sure you follow the hands-on demo very carefully and pay attention to what you're doing and look at which environments you're installing things in. And then I think the answer to number one will be pretty straightforward. If you can answer number one, then I think I've taught you everything that you need to know to start taking on bigger projects.
Thank you so much, Riley. This is super helpful.
My pleasure.
Yeah, thanks, Riley.
Oh, really helpful.